now, Dr. Moebius? Prepare your minds for a new scale of physical scientific values, gentlemen.
The deeper a thing is, the more interesting.
Anti-gravity. Most physicists don't know the story.
We still don't know much more about this in the white world.
I've never heard of it.
The more I ask why,
it's probably classified physics.
It gets interesting.
The role of aerospace companies as holders of potentially basic scientific knowledge not shared with the academic world. Is it possible?
May be wrong, but it's true.
It's the bit of electrodynamics you're not allowed to know.
It is true. You believe it's true.
Yeah, I know it's true.
Disruption is coming.
I'm going to see if we have a few others coming in here just for a bit, so hold tight if you would. And we'll get into the preface, which outlines, again, light, mass, electric charge, and gravity. It's just in 4 pages, so that should be pretty brief. But it's dense because there's math, but I actually think it's pretty understandable and read. So a lot of cool images too. Beautiful images if you just want to take a look and see what a model of levitation looks like. Well, Larry Reed's got it. Hey, how's it going there? Welcome, welcome. I don't know if you've heard about this fella or whatnot, but it's getting passed around. I know Missile Man's familiar, and Science Bob's digging in. It's pretty great. It's only 2 years old. I think it might have had its 4th edition in 22, but then other early editions from maybe 2019, and then there's a 5th edition, which I'm given to believe will be about 1,000 pages. So anyway, here we go. How you doing?
Good, man. That's I love that we're all hosting different spaces. I'm happy to hang out and listen and maybe chime in where I have something to add. But I got tons and tons to learn, so I'm stoked to hear you riff and run the space and teach me some things.
We're learning together. It's a group endeavor. Hey, great, Missile Man. Welcome. Glad to have you. How are you doing? Hope you're well.
Good. How are you? I've got my copy right here in front of me. So if you would like any additional material from inside, let me know.
Oh man, that'd be great. And again, for the room, I have not read everything. I've only read 1/10. That's what was available as a PDF that I could find. I have the paper book coming in the mail in 10 days. So after having read it through, I'm just excited to pare through this first little bit, highlighting anything about torsion, toroids, and twisting. And I think that'll suffice for tonight. And then we can go from there a little bit later on. But I'm going to be looking at the preface and then the 4 sections afterwards. So if anybody would like to follow along, I'm actually going to post that here in the pill as well, so anybody can do the research. One more second. All right, and it should be up there shortly as the second image there. It's just a link to, again, it's a 75-page excerpt. About 25 pages of that is references and several awesome images, of which these are 2 of the coolest up there in the pill. Actually, one more thing. I'm going to post the glossary or the little index or whatever you call it up front. Just huge bingo. All of these things have been what we've been talking about for a long time, and to see it all laid out. In fact, let's do that first. All right, so if you want to know what this book is getting into, we've got a photon model, the quantum vacuum, electromagnetic fore potential, soliton confinement, electromagnetic field dimensions and spectrum, curvature and torsion, polarization effects in a dielectric medium, i.e. the vacuum there, reflectors and dielectric lenses, origin of inertia, trapped waves in a standing wave resonate, confined light, contracted standing waves in motion, Planck aether, love it. Electron model, electrostatics, Coulomb's law, charge to mass, electron charge to mass ratio. It's phasors, quaternions. It's just great, right? So let's jump in here to the preface. This book attempts an explanation and geometrical description of a quantum field theory of light, electric charge, and gravity. No small meal, right? Understanding the fundamental nature and interactions of such quantum fields is facilitated with knowledge of wave phenomena and physical properties of the vacuum that enable wave propagation. All light and matter is composed of quanta that share a fundamental characteristic in that they are composed of quanta that spin, and with spin, angular momentum of only certain discrete multiples of Planck's quantum constant h. Parenthetically, integer bosons and half-integer spin fermions. Again, so that's one whole integer spin bosons, whole integer spins, and half-integer fermions. Why does this manifest? Highly localized, quantized spin wave effect occur, and how does it result in concentrated energy in the form of matter? The estimated quantum mechanical energy content of the vacuum is 10 to the 113th power joules divided by, I don't know, vastly larger by 122 orders of magnitude than the energy contained in the observable. What accounts for this incredible mismatch in the minute fraction of energy in that we can directly perceive and experience quanta with spin and vacuum energy, fluctuations without spin? I'm going to highlight that again. Quanta with spin and vacuum energy, fluctuations without spin. If we connect that back up to what we just read about the fermions and bosons, we might get an understanding of how spin is in play here. We have a vacuum energy that has fluctuations without spin. We've got integer bosons, half-integer fermions. Just what are photons, electrons, and gravitons? How are they created from the seeming void of the vacuum, and how do they interact? Why is the speed limit of the universe set at a certain finite velocity of light? What exactly is electric charge? What is mass? How does mass interaction result in gravitational attraction? We seek an explanation for such phenomena, not just an ad hoc label description without visualization. Several interrelated themes are developed in terms of wave phenomena, energy density gradients, spin waves, and quantum effects in a physical. The subject matter and concepts discussed are necessarily speculative, but are founded on known wave mechanics principles. So I just want to read this again because you'll see this come up as a theme where there's an improvement on the theory for an explanation. You'll see that in a couple of places. We'll get to it. But he says again, we seek an explanation for such phenomena, not just an ad hoc label description without visualization. And his visualizations are great. There are several of them, and I will be posting those as we wrap up a little bit here to make a thread. So that was the preface. Is there anything anybody would like to say before we look at light? And we have 4 sections we're going to go through again: light, mass, electric charge, and gravity in 3 pages. Yeah, right. Let's just get into it. All right. So this is light, a freely propagating photon wave train, or light quanta in empty space, is described as a helical traveling electromagnetic wave of quantized spin angular momentum, moving at the velocity of light. Semper et ubiqui, which I think is always and everywhere, but I'm not sure about my Latin. Photons are classified as integer spin bosons. The physical vacuum as a polarizable medium enables wave propagation and appears ultimately to be quantized at the Planck scale. Now, the physical vacuum as a polarizable medium, there we have how Puthoff, right, to my mind. In the Winterberg-Planck Aether hypothesis, the vacuum is a Bose-Einstein condensate, BEC, a Bose-Einstein condensate superfluid composed of positive and negative Planck mass dipoles. That's our positive and negative. Fundamental particles such as the photon and the electron are viewed as polarized quasi-particle wave excitations of much smaller Planck particles. Electromagnetic waves are conjectured to consist of spin density waves of Planck dipoles, enabling formation of kink or anti-kink solitons. I mentioned the kink and anti-kink solitons. There is an image available. It's hard for me. I should have been more prepared and had everything listed out, and I will in the future, but you can look up kink and anti-kink. I'll put it in the thing later. So electromagnetic waves are conjectured to consist of spin density waves of Planck dipoles, enabling formation of kink or anti-kink solitons. Again, yeah, remember solitons are stable structures there. Similar to the exotic properties of supercooled 3-helium BEC liquid helium superfluid, spin waves are not tolerated by the vacuum, but quickly become localized and isolated quantized vortices. There we go, vortices. Just as a note for this reading, we will be looking at anything toroidal, anything with a vortex, and we're looking at spin as it relates to this new model. So a Bose-Einstein condensate represents a fifth state of matter in which particles collectively act in coherent waves oscillating in phase at the same frequency. The formation of electric charge, little q, magnetic vector potential, big A, electric field intensity, big E, and magnetic field intensity, big H, in a vacuum devoid of matter may be understood in terms of the spatial and temporal density fluctuations and motion of Planck dipoles. The speed of light is a function of the Planck energy density of a polarizable vacuum characterized by the variable index of refraction, big K, little p. So just stopping there again, this advances how Puthoff's work. Photons and electron positrons may be directly interconverted in high energy processes of pair production and annihilation. Any viable model of the photon or electron must account for this interconvertibility. Oscillation of electrons generates electromagnetic waves. Electrons can resonantly couple with electromagnetic waves. Photons and electrons can interact, for example, as plasmonic waves of free electrons in a metal surface, and secondary emission of electrons due to the photoelectric effect, as in a photomultiplier, in an ionized plasma as plasmons, or parenthetically, plasmons, quanta of electron waves. In a vacuum, as in free electron lasers, magnetrons, photomultipliers. In photonic excited condensed matter excitons, and an absorption of photons in photosensitive semiconductor PN diodes or photon emission in laser diodes. Now, that was a lot. That was a lot to take in, but let's go back to the photons and electrons can interact as plasmonic waves of free electrons in a metal surface. That gets very interesting. Secondary emissions can happen in ionized plasma as plasmons, quanta of electron waves. In a vacuum, as in free electron lasers, magnetrons, etc. So, absorption of energy of a photon in a semiconductor can be transferred to an electron as potential energy. Photon emission occurs when the electron loses potential energy when electron-hole pairs recombine. Electron-hole is another thing to take note of. P-N-P junctions of quantum dimensions can provide a storage medium for electrons as quantum mechanical standing wave traps. Man, so I think that this is like an exotic vacuum object here where we can consolidate electronic charge. So I'm going to read that again. P-N-P junctions of quantum dimensions can provide a storage medium for electrons as quantum mechanical standing wave traps. We'll keep moving, but that's incredibly significant. Photonic devices enable conversion of photons into an electron current and vice versa to generate an electrical signal or a photo signal. Photon interactions with electrons can result in motion of matter, as, for example, in particles suspended in an electromagnetic tractor beam by photophoretic forces in an optical trap. So we also have photophoretic to look into, photophoretic forces. All right, I believe this is the last paragraph here for light. In addition to frequency and spin, a photon traveling wave disturbance may be described in terms of curvature and torsion. Bingo. The straight line motion of a photon in a gravity-free zero curvature vacuum reflects a balance in electric and magnetic energy. A change in torsion of a photon in an optically dense medium is associated with effective mass. I'm going to say that again. A change in torsion of a photon in an optically dense medium is associated with effective mass. The processes of electron-positron pair production and annihilation are described in terms of the geometry of a photon helicoid. I'll show an image of a helicoid later. During electron-positron pair creation, the increased curvature K and decreased torsion T of a helical wave train due to Faraday rotation and Levi-Civita effects results in formation of two counter-rotating loops of opposite topological charge. There it is, counter-rotation again. Each loop contains two spinners corresponding to poloidal and toroidal rotation of a toroidal electron and positron spin wave. Electric charge is related to topological charge associated with precessional rotation and is quantized as a result of quantization of spin angular momentum described by Planck's constant. Now we've hit some of the major spinning business in the toroid. We'll pick that up again when we get to the electric section because there is a toroidal electron model. But yes, please, let's take a second here. We still have mass, electric charge, and gravity, but this is a short read.
So what I want to interject here is that I saw that Bob hopped in. If you caught that last paragraph, Bob, it goes into essentially a new model of electron-positron pair production. And what's fascinating about it, not fascinating, what's remarkable about it is that it's very disprovable and it's very verifiable. You could do the mathematics on this and prove very easily whether or not this description matches observation in electron-positron pair production, which is amazing. So anyway.
Good point. Anything that's a good thing will predict something, right, and be verifiable, right? It's true or it's not.
Well, and to follow up, in any transformatively new model of physics that introduces new concepts, things like this. During electron-positron pair production, the increased curvature K and decreased torsion tau of a helical wave train due to Faraday rotation and Levi-Civita effect results in the formation of two counter-rotating loops of opposite topological charge. That's a new concept, quantum electrodynamics. I'm pretty sure, unless Bob can argue that it's not. But to introduce new concepts, if you're doing so in a formalism that's verifiable with experiment, that's a big deal. That's the kind of thing you don't do unless you've shown in your derivation that it's legit. So that's because it's a very effective way to ground the new concepts that you're introducing, which is very hard to do in a new model.
I mean, yeah. And that was very careful, and appreciate that from the believing side and thinking that this is right because of other things. Namely what we've been seeing through the plasma research and low energy nuclear reactions, quote, from Bob Greenyer. All of this connects back to some deeper truth where we see things like counter rotation being pivotal. And so it just seems to be making sigma something else that's also apparently accurate. And I think it's fascinating. So without further ado, why don't we get into mass? Mass is a fundamental intrinsic property of matter attributed to the interaction of electromagnetic quantum fields, i.e. wave interference. In the Einstein relation, mass m equals energy divided by speed of light squared, where E is energy and C equals the celerity of light. The celerity of light. Energy is a measure of wavefront curvature. I think that's huge. Mass is associated with retardation of energy flow and resultant time dilation. Wave energy packets are separated by nodes which obstruct energy flow, restricting propagation. Now that gets us into some of the geometry later on where these nodal points and spaces in between are relevant. Mass corresponds to wave periodicity and is a measure of electromagnetic wave volumetric nodal density. Rest mass is observed only in fundamental particles with electric charge and is a ratio of charge to Compton angular frequency. Fundamental particles are viewed as standing wave resonant structures and not point-like objects. That's big. I'll try and cut down on my comment. Traveling waves such as light and neutrinos acquire effective mass during propagation in regions of higher electromagnetic density. Standing waves acquire mass and inertia as a result of confinement of traveling waves, as demonstrated in work by Jennison and Drinkwater. The self-referral dynamics of radiation trapped in a phase-locked cavity accounts for Newton's first law of motion, i.e., every object in a state of uniform motion tends to remain in motion unless an external force is applied to it. Hence, there is no need to attribute inertia to instantaneous interaction with the rest of the matter in the universe, according to the Mach hypothesis. Mass and inertia are local phenomena. Mass may be understood as an interaction of electromagnetic fields resulting in accelerative wavefront curvature, without recourse to the hypothetical, vaguely described Higgs field with unexplained mechanism for imparting mass to massless particles. The confinement of light, consisting of massless photons in a fixed reference frame of a cavity resonator, results in the creation of mass and inertia. At a sufficiently high energy level corresponding to the rest mass of the electron, the imbalance of electrostatic and magnetostatic fields results in topological confinement of a photon within a fixed volume of Compton radius, big R, little c. Hence, fermions may be interpreted as spinning, phase-locked, topologically confined, standing wave resonance structures with electrons and positrons as the fundamental building blocks of matter. In general, the motion of a push-pull phase-locked cavity resonator consists of an oscillatory sequenced series of accelerated jumps interspersed with coasting periods of constant velocity. In this respect, a cavity resonator is somewhat analogous to an inflated bouncing rubber ball, alternately compressing and decompressing without internal dissipative losses. I think that might be adiabatic. The rhythmic pulsation of a phase-locked resonator in motion generates longitudinal and transverse electromagnetic waves with frequency which varies with the cavity velocity. For matter, parenthetically, compose resonant electromagnetic standing waves. For matter in motion, the Lorentz contraction is interpreted as a physical wavelength compression due to variation in electromagnetic field energy density, as measured by vacuum refractive index. A phase-locked resonator in motion exhibits an oscillatory, pulsing compression and expansion, emitting dipole radiation transverse to the direction of motion. Interaction of these radiated waves with nearby electrons via the electromagnetic vector potential A results in coupling of n number of electrons, increasing their effective collective inertia as n squared. The Lorentz transformations of motion in terms of velocity ratios compared with Ivanov-Lafreniere standing wave formations in terms of standing wave ratios are shown to be equivalent. Ivanov and Lafreniere have shown that standing waves undergo wavelength, parenthetically nodal, contraction in the direction of motion. An object in motion relative to a fixed observer undergoes a Lorentz contraction, wavelength compression, in the direction of motion, and a Lorentz Doppler shift in frequency, reduction. The wavelength compression is a physical result of an increase in the vacuum energy density. Moving clocks, which are made of standing matter waves, undergo time dilation as a result. This is in keeping with de Broglie and Schrodinger's view that matter waves are real physical waves and not merely particle location probability amplitudes described. This is in keeping with de Broglie and Schrodinger's view that matter waves are real physical waves and not merely particle location probability amplitudes described in the Born interpretation. The electromagnetic wavelength contraction and frequency shift in a polarizable vacuum accounts for mass in motion and gravitational effects, including the energy change, deflection of light, gravitational frequency shift, and clock slowing. The speed of light c appears invariant in all inertial frames due to Lorentz contraction of the measurement apparatus and a concomitant Lorentz Doppler frequency shift. Space-time remains Euclidean over scales comparable to wavelength. The apparent Lorentz space contraction and time dilation are the result of contraction of the nodal distance of the standing waves, which constitute the length of measurement. Time dilation is equivalent to a change in the size of the units of measurement, which are undetectable to an observer as both the object and the co-moving measurement apparatus undergo Lorentz transformation. Fundamental particles of matter exhibit properties of standing electromagnetic waves trapped in a phase-locked resonator, including Doppler frequency shifts in motion, inertia, which is resistance to motion, and de Broglie wave. Matter in motion relative to an observer exhibits de Broglie matter waves as a modulated moving standing wave. The inverse effect of self-induced motion of matter may potentially be realized utilizing synthesized red and blue shifted Lorentz Doppler waves, parametrically amplified in a phase conjugate, phase-locked resonator, parametric pumping. Energy of motion results from conversion of energy of the pump waves to the contracted, moving standing wave formed from the signal wave and its counter-propagating phase conjugate wave within the resonator. Velocity of the resonator wave system is proportional to the wave phase difference, with acceleration is proportional to the frequency difference. Synthesized matter waves would provide means for inertia modification and control, as well as self-induced motion of matter. I'll say that again. Synthesized matter waves would provide means for inertia modification and control. Such technology would enable electromagnetic wave-based propulsion without wheels, friction, reaction, or expulsion mass. Inverse effects are not without precedent, as, for example, inverse Doppler effect, inverse Sagnac effect, inverse Faraday effect, inverse Compton effect, inverse Spin-Hall effect, inverse Cherenkov effect, inverse Raman effect, inverse Cotton-Mouton effect, inverse Barnett effect, or Einstein to Haas effect, and inverse piezoelectric effect. That was light. So I think that, again, getting into energy being described by wavefront curvature, fascinating. We've also got ratio relationships. And again, I'll try and sidebar all of my connections with everything else I'm seeing, but this reads as highly significant. Electric charge is one paragraph, so we'll get to it in a second. Yes.
Yeah, can I comment now?
Oh, please, welcome.
Yes. Okay, so I doubt it's any surprise that I have a shit ton of objection to almost everything I heard in their last the Yukawa coupling is extremely well understood of how particles gain mass through coupling. To the coupling or strength of the Yukawa coupling determines exactly how much mass a particle will acquire, and everything about the accrual of mass to most other subatomic particles that can couple with the has been observed sufficient number of times in the Large Hadron Collider to call it a discovery. And the excitations that are come from the collisions that give the distribution of particles that you back up and see can only have come from a Higgs boson decaying a sufficient number of times that the Higgs boson, as a major excitation in the Higgs field, has also been declared a discovery. I don't believe a word of what he says about the electromagnetic stuff giving mass to particles, not one word. And that's deeply troubling to understand why I should read a whole lot more of this. But I'm going to, because there's some stuff in that book that is really amazing. Man, I want nothing to do.
Well, the upside, Bob, is that the formalism here of matter as standing waves in this phase locked cavity resonator concept, it's so alien to the Higgs mechanism that it should be fairly easy to tease them apart observably and tell the difference and find counter arguments, counter observations.
Yeah, I don't disagree with that, but I'm just telling you, I think the Yukawa coupling and the Higgs field is extremely well understood and observed. So we'll just have. Well, I'm happy to hear what the experiment will be. I might even think about what the experiment will be, but right now I'm pretty negative.
Yeah, and I think that we're just reading the preface, which is all words, and there's something like 350 pages of math behind each of these paragraphs.
Oh, yeah, believe you me, Larry Reed, single most dense physics author I have read in my entire life.
More than Wheeler?
Oh my goodness, Wheeler was trivial compared. And look, I have the benefit of having 10 years of Wheeler explaining stuff to me, but I had taken 3 years of differential geometry and calculus on manifolds before I ever met Wheeler. So most of that stuff to me was like, oh yeah, thank you for explaining it, because I tumbled to it as soon as he explained it, because I was completely prepared for it, because I took Spivak's calculus on manifolds, and then his 5 volumes of differential geometry and so forth. And I was just gunning prepared to be led through Misner, Thorne, and Wheeler by John Wheeler himself. So, I mean, that's not a good, when you have the horse's mouth telling you how to feed the horse, it's easier. But the other stuff that Wheeler's done, I never found he wrote difficult to read, because he was quite careful in his exposition.
As an unrelated observation, the other thing I found very interesting in that mass section was the dispensation of Mach's hypothesis, description of mass and inertia as local. Those are profoundly interesting claims that one can take to task pretty easily too.
They are. They're, look, anything about anything Mach said, because he's hugely influenced everything after his existence, is going to be interesting to look at, especially if it's possible to find and demonstrate a counterexample. I guarantee you, if we plow our way through this guy, we're going to learn a lot of stuff. And the mathematics, it's a struggle. It's a real struggle.
There's a mastery of geometry in here. It's wild.
Oh yeah. There's absolutely no. I am so grateful that differential geometry and metric space topology and all this other stuff were things I was well trained before I ever went into a high level physics class.
So, what do you think about the energy as represented by wavefront curvature? That seems
I don't mind that so much. I really don't. But look, I mean, the relationship between energy and matter is well known with Einstein's greatest equation. So I mean, it's the other extensions to how mass is acquired through couplings with other fields. We need to demonstrate the coupling with other fields to show there's any veracity. I mean, look, you're getting no argument with me at all for coupling of electromagnetisms through various mechanisms through torsion into the extension to Einstein's field equations done by L.E. Cartan. You're not going to get an argument, but the mechanism for attribution of mass to particles by symmetry breaking and interaction with the Higgs field is well understood.
The only thing is, Bob, you remember what I was saying the other night, that in 1933 we didn't have quantum field theory descriptions of QED, and so I wonder if we go to build a modern Einstein-Cartan model, if we'll find inconsistencies in trying to quantize torsion because we're not dealing with matter wave. So to Nathaniel's question, what do you think about the notion of a wave front being proportional to energy? I think that concept is is baked into this incarnation of matter waves. So if you have these, that comes from this. If we're just talking about EM waves, then sure, peace. Like no modern physicist is going to argue with that. It's what's alien here is it being applied to this concept of mass waves, and I just find it interesting to wonder if one spent a whole lot of effort rigorously developing a quantized Cartan model, will you run into problems by not having a a wave-based mass model? I don't know.
Look, okay, so us as working at this from the kind of this where we are as compared to where lots of other people that we know that are famous are, is we are not going to get much further in quantization of the gravitational stuff than Richard Feynman did in 1950s when he went to the conference called by Wheeler, where Wheeler restarted all modern research with the people he brought together there, with the industrialists paying for it. And Feynman gave paper number 1 at the first of those conferences, and he gave a quantized gravity that would have it works everywhere outside of a black hole and the beginning of the universe, practically. So we can get somewhere with that. But we're going to have to restrict ourselves away from the places where every time anyone tries to quantize the full equations, it blows up. You can't ever get anywhere.
Peace.
Well,
Let Roy talk. Bring Roy up. Let him.
all right. Well, this is a two-way street. Someone else has to also want to come up here. But of course, I'm hoping that I've sent an invite. Come on up, Roy. You know, and let me read that part again. That was so infuriating to you, Science Bob. Mass maybe.
Infuriating is not the right word. It's I don't believe.
Okay. All right. Well, I love it. I love it because someone's right, right? It's either not right or it is. And there's ways that we can get at it, so it's exciting. And it does propose connection to electromagnetism and gravitics, which is the holy grail. So,
good evening, Roy. Thanks for joining us.
Good evening, good morning, good afternoon, wherever you are, humanity. How you doing?
Quite well. Good to have you. I'm not sure if you've been here long. I was going to just read one sentence that kicked things off. We are reading Larry Reed's preface to his book, Quantum Wave Mechanics. Above in the Jumbotron is, you can see an outline of the book. You can see 2 great pages that define things visually, and then a link also to the 70-page excerpt as well of the 650-page book, which will be coming and we'll be going into probably for the rest of my life. So here we are. Welcome.
Thank you, brother. Okay. Where do we begin? I mean, there's been a lot of stuff going on at the moment. To June or July, was it, Bob, when they released the data for the James Webb? And they finally did the analysis. They did a group analysis essentially across a unique set of universities that are geared towards this sort of stuff.
And
Okay,
other observatories besides James Webb. It's they did tons of different data sets, but James Webb is the thing that brought it all together.
Yeah, sort of. Well, what they did, okay, is they essentially discovered that the cosmos is like a timescape. Okay, so it's essentially the expansion of the cosmos is one of a temporal one. Okay, so time is expanding, as it were, and space and time is expanding where there is nothing there. But where there's stuff like entropic clumps and bits and pieces going on, then that slows the rate of time, the flow of time, as it were, and that contracts the cosmos in some way. So it distorts the picture, as it were. As you look out into the cosmos, you get distorted, refractions and warping of space and time. So they're looking now at what they call a modified Newtonian dynamics. Okay, so this sort of flavor of gravity to explain what we're seeing out there in this timescape. Well, this is where, yeah, you got it, my framework, the 5-dimensional framework of space and time, being that extra dimension of the fourth is an extension to time, by the conservation of the moments of time. So I'm not inventing anything new. I'm just applying the same rules that we apply to all things in time to the moments of time, and considering the moments of time themselves to be frames, or a slice, as it were, in that fifth greater whole of time. So a bigger model of time. Now, it doesn't stop there, because essentially that gauge, as we call it, a gauge lattice, is that essentially we are like abstractions, as it were, that are projected within this symmetry of time. We realize or comprehend the cosmos, as it were, through that abstract moment of realization that you, me, and everybody else, we could probably call it a now, okay, a dynamic moment, and the properties of any moment denote the outcomes, as it were. So the entropic information, as it were, the resistance to change from one state to another, denotes our length of time, okay? And that length of time slows the flow, okay? If it's great, it slows it greatly, and you have a differential inertia, as it were. Now, we all know about differential inertias, but we don't quite realize it. If I was to take you in your little mindscape to a canoe, to the middle of a stream, okay, you will not feel the drag of the slowing effects of the bank upon your canoe, because you are at the fast flowing in the stream. But if you move outside of that flow and incur a differential, as it were, then an inertia is born that slowly drags you to the shores of the banks. And it does this by conservation within the flow. So that flow, as it were, we can imagine being conserved. And that's that conservation of it gives us that inverse proportional differential inertia that we now consider gravity. So looking at this model of the timescape, as it were, and considering that extra dimensionality to time, that fluidity to time, we can start to solve some of the biggest problems that have really perplexed humanity since our birth. Okay, well, it answers a lot of other things, but it points to some certain things that may be considered ontological, because it means that we have frames, and it means that that fluid symmetry, the whole of time, as it were, one could consider being like a movie. And it points to us being in what we consider to be a holographic space-time continuum. But here's where the ontology, as it were, ends, in that any construct will require a constructor. So the framework, as it were, provides a framework for physics, puts that into a nutshell. The abstract frames of our reality, as it were, says to us that our consciousness is also linked into this construct, as it were, then, and that it itself must be an emergent phenomena to denote those outcomes. It needs to know what you're thinking. You are part of the fabric of time, as it were, and that entropic order. So it tells us all about how consciousness may fit into it, and it also extends it beyond, as it were, the standard model of physics, in that it transcends. Okay, so in a nutshell, it not just unifies physics, but it completely and utterly puts it into a box and allows a much more holistic view of the cosmos in a far greater, higher dimensional point of view. Okay, so that we can now look at the box and see how we can manipulate the box. Now, I heard some talk about the manipulation of inertia of gravity and all those nice tricks and things. Well, we now know that what I call emergent entropic time, the length of it, as it were, denotes the differential in the flow of time, and therefore gives us the differential inertia. So if one has a very slow rate of time, one will incur huge amounts of inertia. Okay, if one has a faster relative rate of time, then one will negate the inertia. Okay, so there is a way to negate the inertia of gravity by increasing one's relative rate of time to that of one's surroundings. Now, we see certain aspects of the phenomena of levitation in the laboratory. We see it in the forms of superconductivity. Now, my ideas about that frame of reference, as it were, goes back to an underlying emergent phenomena I term dynamic behaviorism, whereby the properties of any moment denote the topological behavioral outcomes form, the states of matter, as it were. How you are contextually denoted within the cosmos is determined by your property. And certain properties hold certain contextualities and topology, and with it, temporal rates of time. Now, some of those rates of time are very, very slow, and some are very, very, very fast indeed, atto and femtosecond rates of time for certain forms of topological phases of quanta. So, if we can emulate the properties of quanta, one will be given the transitional phase, and with it the temporal faster rates of time of quanta. One is also no longer considered of the larger scale, and therefore will not interact with the larger scale. Okay, so it now answers some of the questions that are gained by certain phenomena that we bear witness to, in that some of those attributes, while gaining that zero inertia state, as it were, for the negation through the increased temporal rate of time, okay, that leads to other issues and other questions for us as a species, okay, in that, yes, it provides Star Trek, yes, it provides temporal teleportation, and a lot besides, but we're going to have to be responsible, okay, because now this means that we can go potentially anywhere. And any motion, as it were, without movement, because now we're opening the realms to temporal teleportation, then we have no causality issues with the speed of light and other things and other issues. So it is a complete paradigm shift in our perceptual understanding, holistic view of the cosmos. It opens up a whole paradigm, as it were, of problems for us ontologically. It also gives us the ability to travel the cosmos. Welcome to the post-Newtonian Einstein era of physics. I'll end it there.
So let me jump in for a second and just give people what it is that the cosmologists are jumping up and down about that was observed with the James Webb Telescope. Of course, there's been this Hubble tension that's been going on for a while. And other telescopes, along with the James Webb Telescope, have refuted the underlying assumption in the lambda CDM model of cosmology. And what is this underlying assumption? That the mass, the visible mass and energy in the universe is uniformly distributed, which it is decidedly not. That is just an absolute false assumption that mass and energy are uniformly distributed in the universe. They are not. So you've seen pictures, I'm sure, of this massive network that looks like a graph of distribution of galaxies and clusters and other things and what look like filamentary strings. So this is an utter refutation of the underlying assumption of lambda CDM. What is another upshot of that? The upshot of that is where there's not one of these filaments, there's a massive four-dimensional void. Three-dimensional is what we can see, but it's massively huge. And every time a photon leaves one of these regions where there's a lot of energy and matter, and therefore there's some dilation going on, and enters one of these voids, the dilation disappears. So when we look from the edge of the observable universe with our telescopes at a photon that comes all the way to us, it's gone through innumerable filaments of matter and energy and through these voids. And every time it goes in and out, the dilation changes. And so there's been multiple papers now written that says, look, this assumption of expansion, the way we have been claiming it, we can basically back all that out with these dilations and undilations and don't need we don't need dark energy at all. And this is now not a proven thing, but it's a lot of evidence in favor. So we're now about 10 to the third, 3 sigma into what is towards a 5 sigma, which is a detection of new physics. So it's really exciting. And now, but it also opens up lots of other things like the Roy's 5-dimensional space-time and all this stuff. It's really transforming things. It's not yet proven, but I think it's correct.
Yeah, I mean, come on. I called it dilation theory for a reason.
Well, this
And
is
maybe
great.
your geometry will gain traction a long time before Eric's will.
Well, I did hand a gauntlet to him, as you know, but he follows me. We talk. I did say to him, "Come on, publish." And I am still waiting for him to publish. I'm going to be a gentleman about it, Bob. I mean, if he'd have pursued it, if he wasn't stepped on at that time, he would have come up. He would have come to the same realization, as it were, through his own route. He would have come to the same door, just like Gavin has and Martin has, and quite a few names now are actually putting their hand up saying, actually, I believe this. Even Tom Anderson now, the Joint Merit Prize of quantum information theory. Yeah, you know, this is someone equivalent of Weinstein, ladies and gentlemen, that said, Roy's right.
Okay, so this has been very enjoyable, Roy. Thank you for that long recitation, explanation, and detailing. You're always very eloquent, but dinner's here and I gotta leave.
Okay, my brother. Peace and love. See you soon. We are brothers in science, all of us.
Well, excellent. I got a couple of things here for you, Roy, just regarding this paper and time dilation. And I wanted to, there's a couple of things I wanted to read here that I've clipped out for you, and just to see what you think of it. Part of it, Bob's gone, but it was contentious. He doesn't believe it, but it can be believed and can be proved. So that's on the table. But I thought you might like to hear a little bit about different understanding of energy and also explanations of time dilation. What do you say?
Yeah, sure. Go for it, my friend. Go for it. I say that all ideas should be left open until proven otherwise. I mean, come on. I've been banging on doors for 30 years with my idea.
Excellent. The thing is about this, just by the way, I think that this harmonizes and gives a formalism to quite a lot of the things that we've been getting into writ large over the past year, and that we've talked about. But I'll just leave it there for a second. I've clipped out a couple of parts, so I'm not going to reread the entire section, but just some relevance here. Let me first talk about mass, and then I'll get into the time dilation here. This is just a couple of paragraphs. And please, hands or stop me. I'm reading and I can't see. Just jump right in and cut me off if something is interesting. But here we go. Energy is a measure of wavefront curvature. Mass is associated with retardation of energy flow and resultant time dilation. Wave energy packets are separated by nodes which obstruct energy flow, restricting propagation. Mass corresponds to wave periodicity and is a measure of electromagnetic wave volumetric nodal density. Rest mass is observed only in fundamental particles with electric charge and is a ratio of charge to Compton angular frequency. Fundamental particles are viewed as standing wave resonant structures and not point-like objects. Traveling waves such as light and neutrinos acquire effective mass during propagation in regions of higher electromagnetic density. Hence, there is no need to attribute inertia to instantaneous interaction with the rest of the matter in the universe, according to the Mach hypothesis. Mass and inertia are local phenomena. Mass may be understood as an interaction of electromagnetic fields resulting in accelerative wavefront curvature without recourse to the hypothetical, vaguely described Higgs field with unexplained mechanism for imparting mass to massless particles. That was the part in contention. Maybe it's the confinement of light consisting of massless photons in a fixed reference frame of a cavity resonator results in the creation of mass and inertia. One more part. At a sufficiently high energy level corresponding to the rest mass of the electron, the imbalance of electrostatic and magnetostatic fields results in topological confinement of a photon within a fixed volume of Compton radius. Hence, fermions may be interpreted as spinning, phase-locked, topologically confined, standing wave resonant structures with electrons and positrons as the fundamental building blocks of matter. Now, quickly, here are the time dilation segments that we read. The wavelength compression is a physical result of an increase in the vacuum energy density. Moving clocks, which are made of standing matter waves, undergo time dilation as a result. Space-time remains Euclidean over scales comparable to wavelength. The apparent Lorentz space contraction and time dilation are the result of contraction of the nodal distance of the standing waves, which constitute the length of measurement. Time dilation is equivalent to the change in the size of the units of measurement, which are undetectable to an observer as both the object and the co-moving measurement apparatus undergo Lorentz transformation. The observed contraction of wavelength nodal distances is responsible for the perceived Lorentz spatial contraction and time dilation. That's there.
That's damn interesting, I must say.
Well, I'm glad to hear it. Yeah.
Energy density distribution. I did something on it yesterday on this particular thing and had a discussion with Martin about it as well. And I think he's pretty much saying the same thing, but in his language.
Isn't it? Everyone's got their language, doesn't it? Yeah, go ahead.
Yes, but then again, I mean, he's an economist. Come on. It's all right, folks. If you're in the know on this, you'll know.
So we've been building up to this my favorite section where we're talking about charge densities and their relationship here. This is just one paragraph. It's the smallest of the others. This is defining electric charge. So far, we've talked about light, mass, electric charge will be next, and finally gravity. So if you'd please stay around, I'd love you to hear the gravity section as well. This is just a page and a half left.
Yeah, go for it. No, go for it. This is interesting.
Excellent. I'm glad you think so too. Again, room service up in the nest above, you'll find a link to what I'm reading. You can find that this is in the preface, page XII or 12. And well, it's XII, it's not numbered yet. And a couple of images there as well, which I highly recommend taking a look at. They look awesome and they're revelatory with math involved in the image. So please check that out if you'd like. This is the electric charge section, short but sweet, and this is where torsion, toroids, twisting and spinning all come together. So here we go. Traditionally, electric charge has been opaquely described as a separate dimension without geometrical description or explanation of its origin. In this book, a description of electric charge is detailed, relating it to dimensions of mass, rotation rate, and time, which is interpreted as a rate of precession of closed loop standing waves and described by the fine structure. Again, electric charge is detailed, relating it to dimensions of mass, rotation rate, and time, which is interpreted as a rate of precession of closed loop standing waves and described by the fine structure constant. Spin momenta is associated with loop closure, failure defects, or dislocations in space-time and resultant torsion stresses. The electron is described as a helical toroid standing wave formed from an energetic photon traveling wave with a full twist looped into a circle of a radius equal to the Compton wavelength. The photon helicoid may be envisioned as a twisted ribbon spinning around its longitudinal axis. The electron toroid geometry may be described in a twisted ribbon analogy as a spinning closed loop Hopf strip, the simplest form of topological knot. The torus geometry is formed by a rotating charge path in the shape of a Hopf link with toroidal and poloidal components. The half-spin characteristic of the electron arises as a result of a toroidal spin component of Compton frequency W(c) and a poloidal spin component of Zitter-Buegung frequency equal to 2W(c). The imbalance of the electrostatic and magnetostatic energy gives rise to the fine structure constant A. Whoa. The charge to mass E divided by M ratio corresponds to a precession frequency The whirl number, whirl, W-H-I-R-L, the whirl number is found equal to the inverse fine structure constant. Electric charge has mechanical dimensions and represents an angular precession. Spin angular precession creates wave function interference, obstructing energy flow, resulting in electron mass. Charge represents an angular torsion deficit angle and is correlated with a mass deficit. That's electric charge.
Who is this person?
This is Larry Reed, 25-year Lockheed Martin engineer who published this book latest in 2022 as a 650-page volume, with a 5th edition to come out, maybe being about 1,000 pages.
Excuse me, ladies and gentlemen, but
yes. I mean, you guys are my canaries. You know, you're my smarter, been on this, have PhDs or mathematical competencies. It just seems right to me. So, yeah.
No, you don't need them. It's bullshit. Okay. Anybody that tries to throw their PhD at you, stick it back up their ass. Okay, immediately.
Oh, buddy, thank you for yeah. We're just curious people, you know. And thank you so much. Respect your opinion.
I eat them. I eat the arseholes. I really do. I eat them daily. I have predator meetings often with them, and I say, gentlemen, ladies, gentlemen, you know, I come from a point of a unified framework. I hope you can say the same.
God, yeah, and then please describe yours. Yeah.
Yeah, exactly. Now, yeah, I throw that one at them. Now, give me your version. You know, it's all that, and they melt immediately. It's all sniping from the sidelines, and it's all bloody ego, and it's ridiculous. It's move on, twattery at its maximum. Whoever this chap was, he's in the fucking know.
He's in the fucking know. He's in the fucking know.
Yes, especially the topological stuff as well. Yeah, all of that side of it. But like I said, it all breaks down to, if you can imagine, I'm cutting short most of everything, essentially, and encapsulating it all by saying, okay, it's a hologram. It's those frames of reality, as it were. You know, it's a holographic paint event, essentially. You know, so you can break it down as easy as bones as that. But this guy is essentially describing every bloody angle and nature of that.
You know, and this is okay. There's one section left. Let's do gravity, and then we could maybe continue to talk about the significant freely. But I don't want to put too much of myself in between this great work. So there's one more section on gravity that I think we should get into, and then we can talk about the significance that this book is published, frankly.
When did he publish? In 22?
Yeah, man, yes. Years ago, 2019 was, I'm guessing, an original edition, which has been expanded into, this is a 4th edition. The excerpt above is only 75 pages of the now 650, and I'm aware that Larry Reed is working on a larger volume that might get closer to 1,000 pages for a 5th edition. I have the book. It's coming in 10 days. I haven't been able to read it all. Missile Man here co-hosting has been able to go through this more significantly and has a larger degree of mathematical competency, I imagine. So he is aware of it as well.
Cool. Yeah, it's damn interesting stuff. I can't hang around for too long, unfortunately. It's getting rather late here. It's 3 a.m.
All right. Well, let me should we just talk a little bit? No, I'd like to give you the gravity here.
Go to the gravity.
Okay.
Do it
Got
now.
it. All right.
Go.
Okay. All matter is composed of quantum oscillators emitting electromagnetic waves over the entire electromagnetic frequency spectrum. Gravity is viewed as a standing wave interaction between coupled oscillators interacting via electromagnetic traveling waves, e.g., bosons. Inertia and mass are the result of standing electromagnetic waves generated by an isolated oscillator within a phase-locked resonator, e.g. fermions. Electromagnetic resonant wave interactions in a polarizable vacuum, Puthoff, in a polarizable vacuum model in Euclidean space exhibit geometrical space-time curvature consonant with Einstein special relativity, general relativity. Acceleration of gravity is the result of a spectral energy density gradient. Acceleration of gravity is the result of a spectral energy density gradient and corresponds to the rate of change of rapidity. Inertial mass of matter in motion and gravitational mass of matter in a gravitational field are equivalent, as both arise from acceleration into regions of increased electromagnetic flux energy density and nonlinear frequency dependent alterations in vacuum dielectric constant. Let's keep going. I know it's blowing minds, but
Yeah, go.
gravitation in the Einstein general theory of relativity is ascribed to a curvature of space and time in an abstract mathematical representation. However, the GR theory metaphysical description of gravitation does not describe the physical mechanism for how matter induces curvature or how space-time curvature influences motion of matter. It is argued that space and
Correct.
time are not physical objects, but are merely the mathematical ordering of location of points in space and events in time. Time represents the flow of energy. In an optical theory of gravity, the deflection of light in a gravitational field is the result of variation in the vacuum refractive index, which is a measure of the electromagnetic field energy density. Wow. Gravitation is equivalent to a dielectric gradient force in a polarizable vacuum as a result of local Fresnel zone variation in electromagnetic flux density and vacuum refractive index. The gravitational force F little g is proportional to the gradient of the refractive index. Interference of electromagnetic waves. Go ahead.
Yeah. Yeah, basically what he's describing is the details to emergent entropic time.
I knew you'd love it. Knew you'd love it. Okay. Interference of electromagnetic waves from coupled oscillators produce Moire patterns and Fresnel zones, to be looked up later. Electromagnetic wave front interference creates a Fresnel zone effect between coupled mass source oscillators, concentrating the local flux density and increasing the electric permittivity. Gravitons are illustrated as wave interference of counter-propagating phase conjugate photons reflected from Fresnel zone boundaries. Wavefront curvature provides an accelerative force indistinguishable from gravity. The observed traction of wavelength nodal distances is responsible for the perceived Lorentz spatial contraction and time dilation effect. The metric of curved space-time corresponds to the wavefront interference node metric. Hence, the gravitational field becomes quantized and space-time remains Euclidean. The quantized gravitation field may be understood as purely an electromagnetic phenomenon. As such, gravitational fields may be subject to modification by alteration of the local electromagnetic field density to check the propensity to fall or neutralize weight. Sorry, I'm getting excited.
Yeah, good.
Yes, a little bit more here. Ability to effect at-will modification of the gravitational spectral energy density gradient and concomitant neutralization of the local gravitational frequency shift differential will mark a significant technological achievement and prove a benchmark of human intellect, for God's sakes.
I know. So it's a no-brainer, isn't it? Yeah, energy density. Yeah, it leads to time dilation, leads to the curvature.
It's awesome. Holy, sorry, I just got a message. I got to leave that alone. Too many mind blows. 1 second.
Well, what that guy was saying as well is essentially any form of directed entropy gives you that tug.
So just a little more here, and we'll finish with the gravity section. We're in the last page. A conundrum of modern physics is the apparent incompatibility between quantum mechanics and general relativity, each of which have had considerable success in describing aspects of the physical universe. It is asserted that the mathematical construct of space-time curvature, as represented in Einstein's general relativity, applies not to space-time itself, but rather to wavefront curvature and nodal contraction of electromagnetic waves in space-time. Based on investigations by Michael Faraday, the existence of electromagnetic waves theorized by James Clerk Maxwell was experimentally demonstrated by Heinrich Hertz, Nikola Tesla, and others. The exact nature of just what is doing the waving in electromagnetic waves has remained a mystery. What constitutes Faraday's invisible electric and magnetic field lines of force? What Planck scale vacuum elements are in contact to enable transmission of force? What accounts for the apparent tension and pressure? The vacuum is calculated to have enormous energy density and is characterized by quantum oscillators with 0-point energy. Boom. What is the nature of such oscillators that support propagation of electromagnetic and gravitational wave disturbances? In this book, electromagnetic fields and waves are conjectured to be disturbances in the physical vacuum composed of rotating, quantized Planck dipoles consisting of coupled positive and negative Planck mass with net zero mass and angular momenta. Electric and magnetic field lines are manifestations of temporal and spatial spin alignments of groupings of adjacent Planck dipoles. Significant. Keep going. The Planck vacuum is represented as an exceedingly dense energetic medium composed of Planck mass dipoles with characteristic Planck impedance and under symmetry breaking. Planck impedance and under symmetry breaking, easily induced to spin. Bosonic and fermionic fields correspond to resonant spin wave interactions between such dipoles. Bosonic and fermionic fields correspond to resonant spin wave interactions between such dipoles. Bosons represent traveling waves, while fermions represent standing wave structures, both of which are electromagnetic. The space-time metric is a mathematical overlay description of electromagnetic interactions, characterizing the relative positioning of objects in space and ordering of events in time. The quantum vacuum may be understood as a foam of positive and negative curvature and mass. Planck masses are the underlying quintessence or stuff of the vacuum and are thought to arise spontaneously as a result of vacuum instability from a state of nothingness. Dark energy represents quantum wave function dissonance driving universe expansion. Concept and inspiration is the aegis of design and invention, knowledge and understanding. All right, that was Gravity in the preface.
Yeah, pretty much bang on, really.
It's amazing. We'll be diving into this much more, and I can't say I understand, but I can see a little. So thank you for being here with us.
It's an energy. No problem. He's saying that it's the energy stress tensor. Okay, so but that energy stress tensor, as we know, where we have in that timescape that we've just seen with the details of James Webb, is that it's clumpy out there. So it's like an entropic soup, as it were. And the more complex the entropic soup, the slower the rate of time for that particular region. The determination, as it were, of what's there, which is slowing all of the mechanics, even at the quantum scale, which has given us that differential inertia, essentially. So yeah, it's all those. And it's really funny that he's now going into spinners, essentially, isn't he?
Yeah. And I think that torsion, tors, toroidals, spin, oscillation, resonance are all in play here.
Oh, yes, they're all very much linked. I was saying, someone was asking me how best can we get the most, produce this sort of effect of emulations of quanta. I said, well, do what quanta do, toroidal.
Yeah, so in his gravitation section, by the way, his treatment, so it's interesting because I was realizing this to a greater degree while you were reading the preface. It's important to distinguish that when he describes torsion, it is a little bit different in the sense that it's more broad and more all-encompassing than if you read Einstein-Cartan from 100 years ago, because it's not necessarily just torsion of a gravity wave. Because he frames gravity as an ultimately electromagnetic phenomena in nature, when you get into the section about gravity proper, he adopts the Einstein-Cartan-Evans, which actually was just presented on at APEC last week by Eckhart Horst, the co-author that worked with Myron Evans before Evans passed away a number of years ago. So if you're interested in ECE, there's a talk on APEC from like a week or two ago.
Oh, that'd be very interesting.
Yeah, and that's great. I mean, one big takeaway is I love that we have someone advancing Hal Puthoff's model, right? His polarizable vacuum, a 0 point energy explicitly. This understanding of, yeah.
Yeah, yes, his mention of it explicitly outlines it all. I like I say in this anyway, I leave it up to Uniservant to do the detail, as it were, because we argue amongst each other. It's an ongoing debate, as you can imagine. I take the more holistic view on things, so I'm very much open to any interpretation, essentially within the physics framework, as it were.
Yeah, for sure.
I leave them to argue amongst themselves.
Yeah, and I mean, from my personal point of view, I mean, I think things go far beyond, this nuts and bolts mathematical, white paper stuff. We can get into
Oh
all of
yes,
that, of course, but I feel like, the smaller pill to swallow is electrogravitics.
yes.
So, it's just yeah.
But I'm surprised he didn't mention ether.
Oh no! Oh, Roy, you just came in too late, buddy. Explicitly ether. There's a section where he talks about the terms that are going
Oh,
into it. No, man, we got the ether in here. It's happening.
Well,
Um,
essentially, his
I
definition of these Planck dipole units that make up the quantum vacuum, he's borrowing that from, he named it somebody's ether theory in particular. He did name it.
I think it was the Planck ether hypothesis.
I see it as simply a transitional phase in itself. A symmetry.
Oh, it was the Winterberg Planck ether hypothesis.
Yep, I just found it. Which describes the vacuum as a Bose-Einstein condensate superfluid comprised of positive and negative Planck mass.
Right. He is using exactly so. See what I mean? It's all the language is different, but it's all the same
Well,
stuff.
interestingly, there is mention of gravitons, and I don't, we just read an overall summary. So what exactly he's considering to be a graviton, I haven't sussed that out yet.
I think that where I've read it, it's like quote, or I think it's like understood as this, understood as gravitons, and then he goes on to describe a more full model. But go ahead.
I don't believe we will ever find any quantization for what is an inertia. I don't think we can abstractly get that small. Do you see what I mean?
I don't think he goes
We are
there here.
essentially trying to make an I think we are, to do that, we would have to form an abstraction of time itself. It's like, how do you quantize time? It's oh God, it's fraught with issue. There's been some talk of having crystal domains and the distortion of crystal domains at the quantum scale being some sort of measurement, as it were, in some degree related to this area of research. I believe there's two universities in China that are doing that line now, which is alarming. We should be doing this.
I mean, that's part of the takeaway here. I wish that you were around longer because I think this runs forward. I mean, there's a lot of revelations. It seems like maybe China has leapfrogged ahead, and all of our secrecy in corporate science has bit us in the ass. And now people are discovering things left and right.
It's exactly the reason. That is exactly the reason why I went public when I did.
Well, so on that note, there is something which I'm familiar with. In condensed matter physics, there's a couple of new phenomena identified. The quantum anomalous Hall effect was predicted in the late 80s, but observed in the lab in 2013. And the neat thing about quantum anomalous Hall effect is that it is such a exceedingly precise measurement, analytically predictable measurement, that you can detect incredibly tiny perturbations, which allows it to be a tool of quantum metrology. So you can actually make measurements accurate to within 10 to the negative 10th, basically about 1 in 10 billion to 1 in 100 billion. So in terms of tools to do new measurements at the quantum scale, to, if there are these extremely weakly interacting forces that previously we thought we had to do high energy physics experiments at CERN to be able to see, these new low temperature systems in condensed matter are offering opportunities to see those things by way of these sort of new measurement techniques that show you extreme precision.
Indeed. Well, one of the biggest revelations of all of this, and one of the things I hypothesize is that, and it's moving towards that way, is the invariant nature of conservational geometric symmetries, in that essentially microcosm can be considered macrocosm. Okay, so we can essentially blow things up, as it were, from the quantum scale to any size we like, and start to prod about with that sort of that sort of stuff. And a team a couple of years ago managed to maintain a state like this for a length of 6 minutes, which was a massive breakthrough for us. And we saw all those endothermics and all that strange transitional phase dynamics, breaking of the symmetries, and all lovely, wondrous stuff going on.
Hey, I wanted to say before you go, Missile Man, if you look at the bottom of XII, I was pointed to this. Let me read this to you, Roy. This is what I was saying. He mentions gravitons, but it's in order to understand the phenomenon in a different way. It's this one sentence. Gravitons are illustrated as wave interference of counter-propagating phase conjugate photons, reflected from Fresnel zone boundaries. Wavefront curvature provides an accelerative force indistinguishable from gravity. Wavefront curvature provides an accelerative force indistinguishable from gravity.
That's really interesting. And what it reminds me of is there's a separate section. So he's describing it as a quasi-particle. And there's a separate section in this where he describes bosons and fermions as quasi-particles, resultant from, coupled oscillations. He's in these Planck dipole fields that he's describing the vacuum, which is of course right up my alley because it's condensed matter, and quasi-particles and condensed matter are like all the bee's knees right now.
Indeed they are. Anyway, folks, I gotta love you and leave you. It's now 3:36. I want to go to bed. Okay. I've got to go to bed.
Get rest. See you again. We'll probably try and do something Thursday and in the future more often and more regular. We're going to hit this hard 2025. We're DIY exposure.
We should do.
Yeah.
We should do. With that gain of 3 sigma, we should be discussing this a lot more about the timescape and what this now opens up, and other ideas, and there are alternative ideas to mine as well, and they should all be discussed. And we should let you be the judge, perhaps. What's the most elegant? I mean, I'm biased. Sorry, kids, deal with it. Peace and love, all. Peace and love.
Thank you, Roy. Much love. Take care. All right, fascinating stuff. So we got through what I wanted to hit as the big mind blowers, just the preface. If anybody would like to come up and speak on this, feel free at this moment. We could edge out away from here to some of the significance, and this hits me personally in theories. It seems to validate many other things. It certifies certain theories of the human tech status quo and what's going on. It explains some things that were being lied about in the public, in my view. There is just quite a lot here. And this is, as fresh as you get 2022. This is laying it all out there. And it validates how Puthoff. I think there was also something in here that reminded me of Eric Davis. I can't think of it at the moment, but this is is ringing true. So I'm happy to have people to figure it out with. The Eric Davis thing was because if you want to, just real quick, if you want to talk about how to work with gravity, then you're going to go to mass. You're going to start playing around with your mass. And if we understand mass as defined by this kind of energy density, then we might have a way of, playing with a counter to it and driving the mass itself down as an energy function with negative energy, I think. But please go ahead.
Yeah, I just wanted to say, as I feel like a hyper lay person in this room, but it's fantastic. There's the things reading through that, like, there's bits that, like, I'm not grasping at all. There's other bits that I'm having epiphanic moments, and the languaging, though, is like music to my soul. So I may not understand the scale and certain things of it or whatever, but it's fantastic. And I appreciate just the commentary you guys are putting on it, and Roy, and like, it's fantastic, man. It's really cool to be a part of this from the full spectrum of well-versed people as we're all figuring it out and being a part of it. Because again, there's just something to this, that is it's very beautiful. It's not, certain aspects may seem dry, but there's like a deep resonance with a lot of the dynamics in here. And it's just like, it's very percolating and titillating to very like aspects of my mind and my being. So it's fucking great. Really appreciate everyone's input. It's helping me learn a lot.
It's really an incredible book. So I found it after, the Larry from NASA, page of it went onto Twitter and caused a big stir. And I did a Google image search on the image and I found the book and I bought a copy and I started looking at it. And I mean, my takeaway is right, wrong, or indifferent. It's not gobbledygook. It's not junk. It's extremely rigorous. I mean, I think Bob said it's the densest mathematical book he's ever seen. So if you pick up, it's highly technical. It's while there's a lot of writing in paragraph form, that's again fun to take away some stuff from at the high school level, the college level. It is extremely dense, extremely technical, and like whether it's correct or incorrect is a question that could take years to answer. It is not simply and obviously junk by any means at all. What it looks like 30 years of work from 10 brilliant theoreticals. Like, I don't understand how any one man built this package. And like you said, he's got another edition coming with like 500 more pages. So, yeah.
Yeah, and also the pedigree of Lockheed Martin, I think that speaks volumes, and has other implications. But this will now be just speculation, and I'm not getting ready to go all into it right now. We'll save this maybe for an after space here. But yeah, I mean, all of this really, we have to take on the board that there's secrecy, right? I mean, it's in the law. So we have to understand that there's a known unknown. It's known. There is more than we know. We know that. It's just, what is it? And these are the threads I think we can pull to draw it out of the dark and into the light, so to speak. Now that venture, maybe everybody doesn't want to sign up for it, but it's maybe a dangerous one. It might be a suicide by education, but I think it's worth trying to figure out what the nature of reality is. So, all right. Thank you all for joining. I probably will start up an after space just for more generalized talk, and we can leave out the harmonic oscillations. We will be looking at this. I want to dig into the plasma. I'm going to reach out to Bob Greenyer about all of the toroidal functions that are going on specifically within the electron model. There was another thing that stood out to me when he was talking about electron. I think he's talking about charge clusters, basically. And then we can get into exotic vacuum objects from this as well. I think this might be expanding it. So a lot to dig into. This is just the first 4 pages. It's the preface. So highly recommend reading it for yourself so you can go slow, look things up as you need to, take pictures. This was my second reading through it, and I'm looking forward to more. But thank you, Missile Man, for being here, and everyone else who's listened and spoke. It's been a joy, and we'll have more. So thank you all, and hope you have a good night.
This is a donut.